Have you been to Mars? Me neither. But according to an LLM or a large language model out there, I have been to Mars in 1950, right? It is not uncommon for the large language models to generate misleading data such as this, right? Let's look at some more examples, right? A large language model creating or generating a Python script that looks logically correct but totally unexecutable, right? Another example could be a mathematical or a financial calculation that the large language model creates is incorrect, totally misleading and incorrect. It could also be giving you incorrect dates on major events such as moon landing, right? These are all very good examples of AI hallucinations. So AI hallucinations is a very well-known phenomenon by the large language models. This is where the AI models are generating misleading and factually incorrect and sometimes even nonsensical responses for the questions you are asking. You see hallucinations commonly in question answering or when you are asking the models to generate summaries. So the hallucinations can be statistically inaccurate and factually incorrect, right? So why do hallucinations occur? There could be two reasons, right? And there are two types of hallucinations. One is intentional, where, for example, threat actors can be injecting malicious data into your corporate data, right? That is leading to adversarial hallucinations, right? It is a quite common cybersecurity example of hallucinations. Now, the second one is the unintentional hallucinations. These hallucinations occur because of the innate nature of the large language models being trained on large volumes of unlabeled data. When you are using unlabeled data, and that too large volumes of it, there could be misrepresentations of these facts, and there could be conflicting information. There could be misleading and incomplete information also, which causes the models to generate incorrect representations of responses, right? Sometimes these unintentional hallucinations are also caused by the encoder and decoder models that are very foundational to the large language models. So, we are beginning to understand hallucinations quite well. And we have also developed and leveraged techniques, the prompting techniques that are out there in containing the AI hallucinations. I'm going to talk through 5 different prompting techniques that we could use to contain the hallucinations in your large language model responses, right? The first one will be the temperature prompting technique. It is actually a parameter that the sequencing models leverage, and the value of the temperature can typically be between 0 and 1, right? The temperature parameter is going to determine how greedy your large language model is going to be, right? If the temperature value is 0, then it is going to be a lot less greedy, right, in being accurate. And if it is the temperature value is more 1, then the model is going to be very greedy and gets very creative. Now, let's apply the temperature values 0 to 1 in with a business document where you are interested in extracting facts like in net income or a company name, buyer, seller, etc., or also the SLAs of a contractual document, right? And you also have another document called a creative document where you are going to ask the large language model to create a poem or write a sonnet in either Keats style or Milton style, right? So, if I were asking the large language model to extract facts, I would give it anywhere between 0.3, right? And if I am asking the large language model to extract SLAs from a contractual document, I could go from 0.5 to 0.7. However, if I am asking a large language model to write a sonnet, I would be giving it a whopping 0.8 because that makes the model very flexible with the words in generating that song and a sonnet. Okay, The next technique, my favorite, in generating very effective outcomes is the role assignment. In this, you are controlling the outcomes of the responses from the large language models by telling it to take a role of a certain persona, right? For example, if you have a patient document, right, you can tell the large language models to be a doctor, to go through the symptoms and come up with a diagnosis, right? That is for a medical kind of a document. If you were to create a creative document, then you can tell it, think like Keats and write a poem, right? Or think like Milton and write a sonnet. That is how you are going to tell the model to focus on the outcome that you want to come out of those models. So the third very effective technique is called specificity, right? This takes the role assignment to the next level. In specificity approach, you are giving specific data, rules and formulae and the examples to the model to follow and get you the results that you want, right? This is a very good example of using the few shot prompting technique, right? Like chain of thought, react, and this works very, very well, particularly when you have scientific calculations or you have financial calculations and you want a model to arrive at a solution in a very methodical manner, right? This is also a very good example of writing code, for example, right? Writing code to solve a problem, right? Use that in those examples. So the next and very effective technique, and by the way, this is my really favorite approach, is content grounding. This is where you are making the large language models to look into your domain data, right? Well, even though it is trained on the internet, unlabeled data, it is now focusing on your data to respond to your questions. It is very useful in the business scenarios, right? Where you are asking for security breaches or risk in a contract, etc. So the large language model is focusing on your content and getting you that response. By the way, RAG is a really good approach to use for content grounding, retrieval augmented generation. And the final and also a very effective prompting technique is the providing instructions of what to do and what not to do to the large language model, right? In a business document, supposing you have 5 types of risks involved, but you are only interested in the infringement risk. So you can tell the large language model to focus on the infringement risk. Similarly, if you want to create a song or a poem by Keats and you want only happy poems, you can tell the model to do so, right? It works very well. So try to incorporate do's and don'ts in your prompting technique. There you go. These are the different techniques you can use to contain hallucinations. It is so critical to do that because you want to avoid harmful misinformation, avoid legal implications, and also build trust and confidence in leveraging the generative AI models. Thank you for watching. Before you leave, please click subscribe and like.